Hello everyone. Today we are going to solve Leetcode problem number 2. Add two numbers, and probably I might need to use my whiteboard to explain this problem to you. And where is my pen? I believe it's here. Yeah. Let's first read the problem out loud and understand what are the constraints and what is convenient and what is inconvenient. Given in this problem, you are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order and each of their nodes contains a single digit. Add the two numbers and returns the digit as a linked list. You may assume the two numbers do not contain any leading zeros except the number 0 itself. So what they're actually trying to say is, let me open my whiteboard. We remember how to do an addition from elementary school. I hope everyone remembers that. And very messy what I have. So for example, we have for example we have 243 and 664. So we add both of them. So 4 plus 3 is going to be 7 and 6 plus 4, now this is going to be a two-digit number, so we're going to have a 0 over here and a carry over here, and we add all of them. 6 plus 2 plus 1 is equal to 9, so we get 907. This is how addition in elementary school looks like. So we are given non-empty linked list. So what that means is, suppose we are given a number, let's say 564 as a linked list, and it's being added. So the other number would be non-empty. I mean, there would be at least something over there, let's say 10, so it would equal to 574. Okay, this cannot be empty, cannot be empty. Okay, and then the problem says the digits are stored in reverse order. Let's not worry too much about that right now. And each of their nodes contains a single digit. So all the nodes are containing a single digit. So, and they are stored in reverse order. So okay, let's create an hypothetical example. Let's say we are adding 3 6 2 and plus 4 4 4 5. So the fact that they are stored in reverse order makes it really convenient. I can write 4 5 4 4 and 2 6 3 3, and now if I add them, I can start adding them from the ones place. This is the ones place, and that's how it makes it convenient when they are given us the linked list in reverse order. So 5 plus 2 is 7. Now 4 plus 6 is 10, but we have a carry over here, so this becomes 0 and this becomes 8 and this becomes 3. So what we get is 7083. So, and then let's continue. Let's say let's see how we can write this in our code. Alright, so I just remember one more edge case that we can forget, and it's pretty obvious to forget, is that suppose we are adding let's say 7 plus 9. Now we know obviously this is 17. Okay, sorry, 16. I'm so sorry, this is 16. uh, but in our algorithm, let me rewrite it. 7 9. So this is going to give me a 6, but our carry is gonna go here, but there is nothing here. So let's assume there is a 0 here, and we put a 6 here, but we need to tell our algorithm that there is a carry 1 over here, so this would go here in the linked list. There's 6 inside. Okay, so this is one of the edge cases that many people trip off, and we have covered this as well. That's why probably this problem has a lot of dislikes, and so now let's consider all of these edge cases into our code, and
Let's actually get into the code, and it'll probably make even more sense. So the first thing we want to do is, we know we're creating a resulting linked list, so I like to just put a dummy node to not have to deal with any of the edge cases of inserting into a linked list.
So that we do not need to worry about.
And our current
edge
pointer is going to point at the position that we're going to be inserting a new node or the new digit into. So we're going to iterate through these nodes. Now, how long are we going to be?
Pointer is going to point to the dummy node. Okay, the current pointer, and now we're going to iterate through the list, and how we're
iterating through them while either of them have.
So when our algorithm runs, when either L1 or L2 has got digits, so we can write while L1 or L2 then our while code, then we do something inside. So while L1 or L2, what we're gonna do is v1 is equal to L1 dot val, and you can see why we're putting val here, because we have given the commented instructions over here. If L1 and that's not the case, we're gonna put a 0. Okay, and now we're gonna do the exact same
now
thing.
We actually want to add them together, but hold on, remember we had a carry that we have to maintain. So I'm going to have a carry value and initially set it to 0 outside of our loop. So
alright, so now we will make our new digit. I hope the recording is going here. So now we're going to make the new digit in our linked list, and new value is equal to v1 plus v2 plus carry, and that's literally elementary school mathematics. And what is the value of carry? Carry equal to the value what we're gonna get and divided by 10. That is the carry. Okay, and the val is going to be val mod 10. So carry is equal to carry divided by 10. This is the number of times the value is being divided by 10. So it's gonna give us 1 or 2 or whatever, and the value is let me explain it on our whiteboard. So suppose I want to find out the carry. I add 7 and 8, it's gonna give me 15. So I take 15, I divide it by 10. So when I divide 15 by 10, it's gonna give me a 1. Okay, so this is the carry that we are having. Okay, and what is the value that we get? The value that we get, again, it's the modulus of 15 divided by 10. So I put a 1 here, 10 and 5. So that's what we've done over here. Okay, so I've got the val, and I've got the carry. Okay, now let's continue forward. So then we update our current next list. Current dot next equal to list node, and we put the val inside it. Now we're gonna update our pointers. Now we're gonna update pointers. So current equal to cur dot next. Okay, L1 equal to L1 dot next if L1, else none, and L2 equal to L2 dot next if L2, else none. Okay, but remember that edge case that we had, if, like, for example, I'm adding how do we add it? Yeah, for example, I'm adding 6 plus 7, and so we are already having a carry over here. We might at this point we might just want to return the dummy.next linked list, return dummy dot next linked list. But we remember that this edge case, that if we already have a carry, so we're gonna add one more condition into our while loop, that while L1 or L2 or carry, and we're gonna define carry up here outside our loop, carry equal to 0, and then we're gonna return dummy.next. And now let's run it and see if it works or not. Oh, okay. Okay, I think I've made oh, sorry. Okay, so there is this naming error. Current, okay, save. Case 1, case 2, case 3 all have passed, and we have successfully completed Leetcode number 2 in 12 minutes. Thank you very much. Hope to see you in the next one.